Okay, so here's a problem to construct the influence line for the reaction at B. So this will be the first problem that we've done up here on the screen. So let's try the equation method. So remember what we're going to do first, and just to help you visualize this, I'll redraw the free body diagram of the structure. The problem is asking for the reaction at B, so I will assume that my reaction at B is up, call it By, and over here at A, I'd have a reaction AY. I'll put my AX force there, but we're not going to really be too concerned with the horizontal component. And then what I'm going to do is, since our load is moving, I'll put my unit load, my dimensionless unit load of 1, and I'll reference it a distance x from the left side. It's a pretty simple problem. I just want to find By as a function of this load 1 at any position x. So how would I do that? How do I find By normally? What's that?
How do you work with the one load?
Anywhere. It's at any distance x I want it to be. Right? So that means this x variable says it can be anywhere on this beam from 0 to 10. Mr. Brown, did you say something?
Some moments around A.
That's a great idea. Let's sum moments about A. So if I sum moments about A and make sure this structure is equilibrium, I should be able to solve for By, right? So looking at the moment about A, what is the moment about A created by our unit load? Positive or negative? Negative. So it would be negative 1 times, what's the moment arm? X. And what's the moment, I left off the dimensions here. What's the moment of By about A? Positive or negative? Positive. And what is it? Well, it's the force By times the distance 5. Is that it? Solve for By. By is equal to x divided by 5. Is that right? So let's plot that. So I'll come down here. Oops. Here's x, and on the ordinate value, I'll say this is By, and it's going to be a function of this distance. So I put in x equals 0, what do I get? 0. I put in x equal 5, what do I get? I get 1. I put in x equal 10, what do I get? I get 2. So there's my influence line with a maximum value of 2. That's it. So where do I go to create the largest reaction at B? What position creates, what's the influence on By? Where would the maximum influence be at? At A? No, that's the minimum, right? What about if I'm standing right over B? Well, it's 1. But what if I go all the way out here to at 10? It's twice as big. That makes sense too. This is like a diving board. If you go stand out here on the very end, that's when the reaction at B is the largest. Now, since we're here, let's go ahead and add to this, what's the influence line for the reaction at A? So how do I find AY? How would you normally find AY if you know BY? Yeah, so let's sum forces in the Y direction. Let's see what we've got. So we've got AY acting up plus BY minus 1. So let's solve for AY. AY is equal to 1 minus BY. And we know what BY is. It's x minus 5. So AY is going to be 1 minus x minus 5. Let's plot that. So here's the influence line for AY. Distance x, 5, 10. Okay, so when x is equal to 0, what do I get? I get 1. When x is equal to 5, what do I get? 0. When x is equal to 10, what do I get? Negative 1. So when I go over here at x equal 10 and create an influence of 2 on BY, I get an influence of minus 1 at AY, which means AY is actually down. Which kind of makes sense. If I walk all the way out here and I'm standing on the free end, yeah, the reaction at B doubles because of that, but the reaction at A actually is negative to balance it. And you'll notice too that at every point, if I add BY to AY, what do I get? 1, which satisfies my original equation. Pretty cool, huh? Any questions about that? There's your first influence line. Will you see one like this on the exam? No way. Similar, I like that. It'll be very similar. All right, so we'll stop.